In this video, we have this differential equation, and the first thing that we want to do is to construct a slope field at the 12 points shown. And so I construct a little table. And one thing that you can note easily is that there are 6 of those values that are so easy to calculate, and that is wherever x or y is 0, then the numerator will be 0 and the entire derivative will be 0. So for any values of x equals 0 or y equals 0 or both, we're going to get a 0 value there. So the next thing that I want to do is go ahead and plot them. First I have a slope of 2, and I'm going to plot that 2 at x is negative 1 and y is 2. But what I like to do is use the points that I have to give me some kind of a reference there. So you can see that I drew a slope of line 2, a line of slope 2 there, and I just want to make something sort of parallel to that. And when I'm done with that, then I can erase. Now, of course, you don't want to be drawing up all on your actual test paper, but I kind of use that as a approximation. Alright, so the next thing is a slope of 1/2. Again, there's roughly a line with slope of a half, and so I just want to make something sort of like that, and I have that. Next, I have all those 0 slopes wherever either x or y is 0. Then I have a negative 2 and a negative 1/2. And finally I have a negative 4 and a negative 1. And with the negative 4 I have no way to approximate that, but it's just going to be a very steep negative line. Alright, so that's my slope field. Next I want to write an equation for the line tangent to the graph at x equals negative 1. So the point I'm given at x equals negative 1 is negative 1 comma 2. And you can see that above. Now, so what I need though is a slope, and to find the slope I'm just going to plug in negative 1, 2 into the derivative. And when I do that I get a slope of 2. So all I need to do now is plug that into my point slope form, and when I do I get y minus 2 is equal to 2 times quantity x plus 1, or simplifying gives me y equals 2x plus 4. Alright, I'm going to go on to the next part. I'm going to move this part B kind of out of the way here so I can use that workspace. Okay, next for part C, we want to find the solution to the given differential equation with that initial condition. So basically, wherever you see x's and y's multiplied or divided together, that's a strong indication that you need to use separation of variables. That's one place where you'll use it. And so we end up with 1 over y squared dy dx is equal to negative x over 2. I'm going to take the integral of both sides with respect to x, and when I simplify that, integral of y, I get integral y to the negative second dy is equal to negative 1/2 integral x dx. I'm going to integrate both of those sides, and I get negative 1 over y is equal to negative 1/2 times x squared over 2, so that's going to give me negative 1 over y is equal to negative x squared over 4 plus c. So this might be a good point to plug in my point, a good time to plug in my point. X is negative 1, y is 2. And when I do that, I get negative 1/2 is negative 1/4 plus c, so c is equal to negative 1/4. So I rewrite, I can multiply both sides by negative 1, and my final step really is just to flip those, and I end up with y is equal to 4 over x squared plus 1, and that's my final answer there. So that takes care of this entire problem.